Alright, let's talk hurricanes. I, being a physicist, like starting with a small number of input variables and finding a large quantity of outputs. So Hurricane Harvey came through not too long ago. Vox reported 27 trillion gallons deposited on Texas and Louisiana. That's a lot of rain. But that rain didn't come from nowhere. So what I have here is an Excel sheet or LibreOffice Calc sheet that has all the math in it already. So I have a conversion from gallons to liters. Which will then convert from liters to kilograms. So then the water. So then we can say we have this much water evaporating off the ocean, and that evaporation is mostly what drives hurricanes. So then we have the energy from that evaporation turned into joules, and then because I already know it's going to be a great big huge number, we're going to divide by c squared to get the equivalent energy for mass. But we also have to lift the water from the ocean halfway up the hurricane height. I came across a paper on hurricanes that said it was 18 kilometers. That's a bit optimistic, but considering that rain doesn't make up that much energy of the hurricane, we'll take it. But it only has to go up halfway because there's some of the water only goes up a little bit, and some of the water is way up here, and that all kind of just averages out. So we only care about from the center of mass, which is 9 kilometers up instead of 18 kilometers. As I said, it might be a little optimistic, but not huge contribution. And so we can convert that elevation with that mass to produce this number here. That is gravity times the height that the water is elevated. So we have m times gh to produce the energy for elevating the water. And then we just add them up and convert to kilograms again because we can. So why don't we put that number in there? That number is 27E12. And so we got all these lovely numbers. So we have that is 2,540 kilograms of energy from the evaporation and 100 kilograms of energy from elevating the water up. For a total of that is 2,640 kilograms of energy. Hurricanes are approximately a Carnot engine. They're not quite Carnot engines because the constant entropy process going from as the water ascends the eye column, the column of the eye wall. That's what it's called, the eye wall. As the water ascends the eye wall, that's not a closed system like the actual Carnot engine is, but numerics tells us it's close enough. So we'll take it as given that hurricanes are Carnot engines. So at the water level, they run about 300 Kelvin because that's what air temperature is. That's 70 something degrees Fahrenheit. Call it round number. Around at 18 at the 18 kilometers? Yeah, 18 kilometers. You should have passed the tropopause, which runs about 200 Kelvin, for a total efficiency of 1/3. So we have this here. That would be 880 kilograms of energy returned to Earth, and the remaining 1,760 kilograms of energy being radiated away into space. So then we figure out where the energy has to go. So here's our energy being radiated away. 1,760 kilograms of energy being radiated away. Gravity is a conserved force, so that means that the energy that goes into elevating the water has to be returned as the water returns. So as the water falls, we get the 100 kilograms back there, which means that everything else should be coming back as wind. So that's 778 kilograms of energy being returned to everything as wind. And as we know from observation, most of the damage is actually caused by wind. So this is that's where all that energy turns as. As it turns out, so Hurricane Harvey lasted about 10 days. It existed before the 10 days before it died out, but it almost died out before that 10-day period began. And so we take the total energy and divide it by that time. 864,000 seconds. There's my units. And produces an average power of 2.7 times 10 to the 14 watts. And as I go look up the paper that I wrote for this, it's around here somewhere. I think it's on the phone. Downloads. 24. Yeah, no. That's 14 there. Yeah, that's an order of magnitude bigger than what the paper that I was referencing said that an average hurricane is. So it's only 10 times stronger, but that's so difference between average and category 5. I think it was category 5. It might be category 4. Order of magnitude. Alright. And that is all I got there. So now we can stop.